Lots of converting. Do you remember Reynolds painting a wall? Do you remember unit rates? When you want to compare two different stores, you want to figure out the price per kilo or per pound. When it comes to speed, you want maybe both in kilometers per hour. That is still all there. Don't forget about that. This first question is a little bit controversial, so we'll figure it out as we go. Okay, so there's a rectangular shape, right? So we've got a rectangular shape that has a length of 15 and a width of 2. Okay, sorry, can't see that. The new rectangle is created using a scale factor of 3/2. K is 3/2. Or if you wanted 1.5. No marks yet. State the scale factor as a percentage. You take your decimal, you multiply it by 100, so you would want 150%. So that's 1 mark. Calculate the new length. New. Okay, so what should I be using? Original new, right? So I'll be using this formula right here. A length of new over length of original. Apologize for it being too cramped in there. This K is 3/2. So length of the new one is what I want. This is already given to me. What's the length of the original? It's 15 centimeters. So you basically cross multiply and divide. So your length is 22.5. If I see 22.5, I'm good. You're good. You get a mark for that. Calculate the new width. Okay, you do the exact same thing. Width of the new. Try to find ways to label things properly. Okay, width of the new. I know that the width of the original is 2 centimeters. So it's 2 times 3 divided by 2, which is just 3, right? So the width here is 3 centimeters, the width of the new shape. So you get a mark for that. So a mark. Every single question is worth a mark unless I tell you otherwise, okay? How much greater is the new area? This is where I want you to think. Remember when we changed everything by K? Remember we had our original, we made the new one? The new is affected by K squared, right? K squared. So you want either 1.5 squared or 3/2 squared. So it's 9/4 times. It says times. So you can do it this way. When it's times, not how much greater, it's like how many times greater. So that's what I would want there. What's up with this, Mr. Jackson? Volume. This is just a flat shape. Like there's no volume. You are right. Okay, but if I were to add a height to this thing, and turn it into a 3D shape, and I create my new volume, what will it have been affected by? K cubed. So it's 3/2 to the power of 3. So this is 27/8 times. Okay? So 4 and 5 each get a mark. If you went 1.5 to the power of 3, obviously, you have a different answer. Yours is 3.375. Okay. So this would have been 3.375 if you wanted it as a decimal. The other one is 2.25. Okay, we skip 6, 7, 8 for now because it's basically the same. Again, so true or false, an object was enlarged by a scale factor of 3. So K is equal to 3 basically. This object's area would be 6 times greater. That is false. It would be how much greater if it's area? K squared is 3 squared, which would be 9 times. You don't have to have this, it's either true or false. True or false, an object was reduced using a scale factor of 3/4. How do we know it's a reduction? What's my scale factor if it's 3/4? It is 0.75, right? It's less than 1 or less than 100%. Yes?
In the part of this question, I did in percentage. And because it's asking how much greater will it be, don't we have to like take 100% out of the 225%?
So you said 125% greater?
No, I said 125% greater.
Yeah.
Is that correct?
That's fine. I did teach it that way. So if percentage-wise, yes, 125 greater. That I'm okay with that. Okay, actually, this is the controversy here. We're talking area. Remember when we did the subtracting, I was only ever looking at the scale factor, like going from one-dimensional to one-dimensional, you know what I mean? This is now two-dimensional, like we're affecting all two dimensions by k. But you can still say that the resulting area, when you compare it to 100%, is 125% greater. I think I'll give you that. Yeah.
And the second one is
This.
237.5.
Yes. 237.5, yes. So Joao is making reference to me saying, if you turn this into a percentage, the 225, that's right, 2.25 times 100 is 225%. It's, if you subtract 100 from it, you get 125, so that's how much times greater. Here you get 337.5%, subtract 100, you get 237.5. Yes, you get the marks if that's what you did. Yeah. Thanks for bringing it up. Question 10. True or false? We have a reduction, and 9/16, if we're talking about the volume, we are going to take 3/4 and cube it. So that would be 27 over, that's 16 times 4 is 1, 4 to the power of 3, I should know this, but it's Monday, 64. So this is false as well. It should be 27 over 64. If the original shape has an area of 43 squared centimeters, everything has a mark, right? The new area of the shape is 688 centimeters squared. What's the scale factor? You're going to use this one, right? K squared is K of the new, which is 688, over 43. And they're both centimeters squared, so that cancels out. So really, you take the square root of both sides. So K is, let me just check here, it's exactly 4. Okay, you get a mark for that. The original volume is this, the new volume is 100, and both of them are in cubic meters, that's perfect. So because we're talking volume, we would like to use new over original. You need to cube root both sides. K is going to be equal to, it's 0.333, right? It keeps going. So you round to 2 decimals. Bless you. Or 33.33%. It's up to you how you want to answer. I'm not gonna take marks off because I don't tell you how to answer exactly. I guess it's 1/3 as a fraction. So if you want to do that, that's fine. Calculate the value of K that would result in a reduction. State, I should say. Anything less than 1. So 0.1 or 1/4 or 7/8. Or if you go 80%, anything would fulfill that requirement, okay? So how many marks is this AC out of? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's out of 10. Make sure your name and last name is at the top somewhere, and you give yourselves a mark out of 10.